All right, so let's talk about second order partial derivative. It says since del f by del x and del f by del y are functions of x and y, we can derive partial derivatives of each of these. We can thus find partial derivatives of higher order. The four possible second order differential derivatives of f, which is a function of x and y, are, so f double x. What does f double x? Now, what I want you to pay key attention to here is the notation. Please pay key attention to the notation. So f double x, you could also write it as, so f double x subscript could be written as f x in bracket and then x. In other words, I need to partially differentiate with respect to x twice. You could also write this as delta square f by delta x square by delta x square. And this is the same as saying delta x of delta f. Ugh. Oh God, these things hate me. Don't worry, guys, I'm coming back to it. Sorry about that. All right, nothing more than what was on top, just covered what I was writing. All right, so whenever you see the f double x, it's you're differentiating partially with respect to x twice. Now f subscript xy is saying that you must differentiate partially with respect to x first and then differentiate partially with respect to y. So note at the end, this is f xy, which is saying differentiate partially with respect to x first and then differentiate partially with respect to y, is written as this: f of 2 of x, so delta 2 of f, delta y, delta x. Please note, the delta x is written second, but it must be done first. The delta x comes second, but what you're going to do is that you're going to differentiate with respect to x first and then differentiate with respect to y. So note here, over here, the x comes first. Over here, the x comes second. But what it means is that you must first differentiate with respect to x and then differentiate with respect to y. So it's a similar thing in the middle. A similar thing here, that f yx is telling me to differentiate partially with respect to y first, then differentiate partially with respect to x. If I write it like this, of f, I need to put the x first. So del x and then del y. Here, I'm going to differentiate partially with respect to y first and then partially with respect to x. So whenever you see it in this form, and you have the x first, it means that you're going to differentiate with respect to x last. And if you had the y first, like in this case, it means that you're going to differentiate partially with respect to y last. So it's a case of the first shall be the last and the last shall be the first, I think. Anyway, let's have a look at it, please. I'm going to do example. I'm going to do example 53.
Okay, so wait, so the first one is a second derivative to x both with respect to x both times.
Yes.
The second one is with respect to x, then with respect to y,
Yes.
then with respect to y, respect to x, and then the last one is respect to y both times.
Yes.
Okay, good. No
All
problem.
right. So let's have a look at this, guys. Changing the color ink. I'm doing 53. All right, 53 says given that z is equal to ln 2xy plus y squared, we're to that del 2z by del x del y is the same as del 2z del y del x. So del x del y means that I must differentiate partially with respect to y first, and then partially with respect to x last. So let's find del z del y. So I'm differentiating this partially with respect to y. It means that I'm treating x as a constant. When you differentiate ln, you're going to get 1 over whatever it is. So it's 1 over 2xy plus y squared. Then I have to differentiate the inside function partially with respect to y. If I differentiate something partially with respect to y, I treat x like a constant. So when I differentiate 2xy partially with respect to y, I'm going to get 2x. When I differentiate y squared partially with respect to y, I'm going to get 2y. So del z del y would be equal to 2x plus 2y over 2xy plus y squared. So next, now I'm going to differentiate this with respect to partially with respect to x. So I'm going to say delta 2z delta x delta y. So this is saying that I have differentiated with respect to y first. Now I'm going to differentiate with respect to x. Well, this is a quotient, so I'm going to have to apply quotient rule. And quotient rule says that if y is equal to u over v, then dy by dx is equal to v du by dx minus u dv by dx all over v squared. So we're quotient differentiation, using the quotient rule, and we're differentiating partially with respect to x. That means I'm going to treat y as a constant. So I'm going to have v. V is 2xy plus y squared. V is the denominator, multiplied by the differential of u, the partial differential of u with respect to x. That means I'm treating y as a constant. I'm going to get 2 minus u, which is 2x plus 2y, 2x plus 2y, and I'm going to have to multiply by the partial differential of v with respect to x. So if I differentiate v with respect to x, v is the denominator. If I differentiate partially with respect to x, I'm going to get 2. 2y actually. I'm going to get 2y. And this is all over v squared. And v squared is 2xy plus y squared. Y squared all squared. Let's pretty it up a little. All right, do I have space around the other side? No, I don't. All right, so I don't know what I was doing. I should have left more space for this. All right, let's just do the best that we can. We'll try and pretty up this a little. I'm gonna get 2 into 2xy plus y squared minus 2y into 2x plus 2y. If I want, I could factor out that 2. And this is all over 2x y plus y squared all squared. All right, so let's just do what I said I was going to do. We have 2 into x, 2x squared, 2x, y plus y squared minus 4y into x plus y all over 2xy plus y squared all squared. All right, so let's do the same thing now, but this time differentiating partially with respect to x first. We're going to differentiate partially with respect to x first. Let's change the color ink so as to not to confuse ourselves because we have limited space. So z is equal to ln 2xy plus y squared. All right, so del z by del x. I'm differentiating partially with respect to x first. I'm going to treat y as a constant. So I'm going to have 1 over 2x y plus y squared multiplied by the partial, differentiate partially with respect to x of the inside function. I'm going to get 2y because I'm treating x as a constant. So this would be equal to 2y over 2x plus y squared. So next I'm going to differentiate partially with respect to y. So delta 2z, delta y, delta z, delta
Sir,
x. Yes,
it should
go
be
ahead.
2xy in the denominator.
2xy in the denominator. Thank you. So I have 2xy plus y squared here. All right, so now we're going to differentiate partially with respect to y. This is a quotient, so we have to apply quotient rule. If we apply quotient rule, it's v, which is 2xy plus y squared, that is v, multiplied by the differential of u. The partial differential of 2y with respect to y is 2 minus the numerator, which is 2y, times the partial differentiation with respect to y of the denominator. When you differentiate the denominator partially with respect to y, you're going to get 2x plus 2y. All right, and this is all over v squared, which is 2xy plus y squared. All right, it looks as if it's coming back out to be the same thing. Can everybody see it? Can you, well,
Yes,
let's
sir.
just finish it. It is the same thing. So this would come out to be, let's just go straight here. This would come out to be 2 comes to the front, 2 into 2xy plus y squared minus 4y into x plus y. And this is all over 2x y plus y squared and our intention. So therefore, delta 2z delta x delta x delta y is equal to delta 2z by delta y delta x. We're asked to show that they were equal, and skillfully we show that yes, they are indeed equal. Please do the next example, everybody. All right, so example 54. And we have f of xy is equal to e to the minus 3x, the cosine of y. So let's partially differentiate with respect to x twice. So we have delta f or del f by del x. So you're going to treat y as a constant. So this is going to be e to the minus 3x, the cosine of y, and then you've got to multiply by the differential of the inside function, which is minus 3x. When you differentiate minus 3x, you get minus 3. So this is minus 3 e to the minus 3x, the cosine of y. Let's differentiate it with respect to x again. When you differentiate e to the minus 3x, you're going to get back e to the minus 3x. Then you have to multiply by the differential of the inside function, which is minus 3. A negative times a negative is a positive. 3 3s are 9. All right, same question, but now this time we're going to differentiate with respect to y. We have f of xy is equal to e to the minus 3x, the cosine of y. Let's differentiate partial with respect to y. You're going to treat x as a constant. So this is e to the minus 3x. That doesn't change. When you differentiate cos, you get minus sine. So this is minus sine y. So this is minus e to the minus 3x sine y. Then we need to differentiate partially with respect to y again. All right, this is minus e to the minus 3x. When you differentiate sine, you get cos. That's the answer. All right, so those are our two answers. Questions or comments?